All right. So I see some kids are still missing, and some of you who were supposed to be here in the classroom are not in the classroom, like Davik. I'm not sure about Praneet though, and Ananya, other kids. Okay. So let's get started. So what are we going to do today in the class? So in the previous class or the previous week, we talked about system of linear equations. So obviously there will be a lot of things that will be new to you. So you must be wondering that, okay, whatever has already been covered, how will I catch up? So don't worry about that. We have total 13 units for SAT preparation. We'll keep going in loop. And wherever you get stuck or anybody gets stuck, I'll come back to that concept, explain that to you in a very simple way. So don't worry about it. Okay? Yeah, Ananya. Ananya is not coming to the classroom today also?
I'll come tomorrow.
Coming tomorrow, okay. I had a friend for you in the classroom. Her name is Moksha, and she is all alone because Daivik has not come over. Arus and Said are not coming. I hope Praneet comes, but we'll see.
Okay.
All right. So in today's class, what we're going to do is we're going to talk about rational, radical, and absolute value functions. Now, before I start, what is your understanding of rational, radical, and absolute value function? What do you know about it? In simplest possible term, how do you describe it? Anybody, you or anybody on the screen. Give it a shot. It's okay. This class is meant for making mistakes. Anybody? Jenna, Ritika, Sara, Neil, Daivik, Riya, Vishal, Eviswa.
Sir.
So today we are going to cover, not today, between today and tomorrow we are going to cover radical, rational and absolute value functions. Now I'm trying to get your understanding of what are these terms that I'm talking about. Yes, go ahead, Jana.
Are rational functions like two polynomials like divided by each other?
Okay. So, I said function. Let's use the term equation. So, rational, radical, and absolute value equations. So, if I relate to what you said, Jana, you are saying that a rational function is where you have two polynomials, meaning, and one is dividing the other one. So, if I say 4x squared plus 3x by 3 minus x. Is this an example of rational function?
Yes.
Yeah. So, if I say rational number, anything that can be written in the form of a fraction is called a rational number. Similarly, if you have polynomials, this is a polynomial or an expression. Okay, polynomial expression. It has two terms. One term, two term. One term. If your expression has only one term, that is called monomial. If you have more than one, that is called polynomial. So this is polynomial expression, the numerator, and polynomial expression, the denominator. Yep. This is an example of a rational function or rational expression. Let's call it rational expression, where you have a polynomial in the numerator and polynomial in the denominator. Yep. If I put equals 1 by 8, this is a rational equation. I have a rational expression here, which with a equal to sign, this becomes a rational equation. Is that okay? What is radical equation then? Anybody? David, go ahead.
When x is like in a square root or like a cube root, like that.
Okay. Give it a shot. No? Don't be shy, okay? I'm like a daddy in the class whom you don't have to be afraid of, okay? So, and here the most important technique for learning anything is being fearless. Make a mistake, be fine with it. Yes, Vishal. Saying something. No? Okay. So let me break it down for you guys. So rational equation, radical equation, or absolute value equation. These are nothing but representation, different types of representations of an equation. Okay. Now let's say if I'm talking about radical equation, this symbol is called radical notation. Okay. If I put something like this is an expression in the radical form. If I put this equal to 5, this is radical equation. Similarly, what is rational? Anything that is in the fraction form is called a rational. So if I put this is a radical expression. What am I saying? Rational expression. Because you have expressions in the numerator and denominator both and in the rational form. So it's called rational expression. I put an equal to this. This became a rational equation. What is absolute value equation? With the bars. Okay. Hey Tansi. And
Hi, sir.
I see one more child has joined. That is Samriddhi. Okay. So for all the kids who joined little late, I'm just doing a repeat of what we are going to cover today. So we are going to talk about rational equation, radical equation, and absolute value equation. So what you see here, when you have a notation for a radical symbol in your equation, that makes it get renamed as radical equation. If your equation is in the rational form, meaning you have expression in the numerator and expression in the denominator, or you have an expression and then you can express that in the form of a rational number and you have an equal to sign, this becomes a rational equation. Now absolute value equation is, if I say, let's say x squared plus 5 equal to 9. This is a simple equation that we have seen 1,000 times maybe. If I put a bar to it, what I'm trying to do right now is, I'm saying that I'm only concerned about the absolute value. I'm not concerned about the plus or minus sign. That is why it is called an absolute value equation. Are we good with this definition so far? Yeah, Ananya, Ritika, Moksha. Your name is good. Your name is easy to remember. There are not many kids with this name. So with most of the kids, what I do is I mess up with their names for a couple of classes and then I end up memorizing it. Your name is little unique to remember, so that makes my job easy. Yes, Derek.
Wait, so for rational functions, x can be divided by and x can't divide by, right?
It can, I mean, simple way to look at it is, as long as you have an expression in the numerator and denominator or, okay? So any equation, let's see if I have 5x squared plus 9 equal to 8, this is not a rational equation yet, but if I divide this by, let's say another, by 8 always, let's say 6. Now it looks like a rational expression on one side of the equal to. It will be qualified to be called a rational equation.
Yeah, but like, say it for like a function, but if I have like f of x equals to 1 over x, or like something like that, would that still be considered rational?
Yeah.
Okay.
Yeah. Anything that, see, no matter how far we go, how many gray hairs we grow, the basic concept would not change. I know none of you have gray hairs yet, only it's me. But here, when you look at this, you'll have to bear with my dad jokes, okay? That's something that comes free with this class. Okay, anyways, coming back to this one. So, my basic understanding is anything that can be represented as a fraction is also called rational. So if I have a function or an expression or an equation which is good to be represented in the form of a rational number, I can add a word rational to it. Yeah? And it doesn't say ever whether x is in the numerator or in the denominator, or the variable is in the numerator or denominator. There's no classification or there's no categorization based on that. So you don't really have to worry about, okay, whether my x is in the numerator or the variable is in the numerator or denominator. It doesn't really matter. If I have 1 by x plus 9 equal to x plus 3, this is as good a rational equation. Yeah? Okay. So far we have only dealt with, or we have tried to kind of wrap our head around what is the definition of these three types of equations. Now let's muddle the water a little bit more so that we can relate to it and we can apply our learning of things. Now let's start with the radical equation, okay? Let's say I have a radical symbol and it's an equation. I will call this a radical equation. So far no contention, no doubt. Nothing to fight with your teacher so far. Vishal, Sarah, Thansi, everybody okay? Viswa with me? Okay. Now we have to solve for x. Okay? How we will solve? Any thoughts? Yes, Vishal.
We can like square both sides and like we can try to use the quadratic formula
Okay.
and set it to 0.
Okay, so whatever Vishal said, I'll just do it, okay? Sometimes I feel you guys know more than I do. So let's do that. So whatever Vishal said is what I'm going to do, okay? He said you have a square root of x. So let's do one thing. Square this side and hence square this side also. Yeah, that's what you were saying, Vishal?
Yeah.
Okay, so now when I do a square of a square root of x, that becomes x. Yeah? And when I do a square of this is a minus b whole square. That becomes a square minus 2ab plus b square. Yeah? And then with me? Okay. So this became x equals 4x square is 16x square minus 2 times 4 is 8x. 2 times 4 into 7. 2 times 4 is 8 times 7 56x. 56x plus 7 square is 49. So that gives me, let's get everything to one side and make it a perfect quadratic equation. So this becomes 16x square. This x will also go to that side. So becomes minus 56x. And this goes to the other side of equal to becomes minus x plus 49 equals 0. So far, no problem. Yeah. And stop me if I'm going way too fast, because you will probably take a couple of classes to get to my speed. I mean, if my speed is not good enough, or I will slow down. So just keep interrupting me wherever you find me going fast or slow. So now I have 16x squared minus 57x plus 49 equals 0. And I have to solve it for x. Once I solve it for x, I will have the solution for x. Yeah? How do we solve it? There are three methods. Tell me if you have heard about it. It's okay. I'm just trying to get an idea of what, and in the first or second class, kids become a victim of my questions so many times, because I'm just trying to get a sense of where I would want to slow down, what you know, what I would need to repeat. So if you have a quadratic equation, do you know how to solve them? Let's multiply these two. So there are three methods. I'll come back to that. Okay. So first method is you try mapping it with one of those standard formulas of a plus b whole square, or a minus b whole square, or a square minus b square equals a plus b times a minus b. You try mapping it to one of the three formulas if you see there is a correlation, or else there is another method where you look at the coefficient of the x square and the constant, multiply them and see how you can break that factor to split this into two parts. Or third is the magic wand, where you have a quadratic formula which says if you have a quadratic equation, look at the a, b and c, and then the two values of x would be minus b plus minus b square minus 4ac divided by 2a. Yeah? Where a is your coefficient of x square, b is your coefficient of x, and c is your constant. Yeah? So I'm not doing all this right now because this doesn't look straightforward, one of those algebraic identities. So I'm using my magic wand. Okay, as long as I remember this formula, we are good. So what is so how do you get a, b and c? This is your a, this is your b, and this is your c. Plug it here. So x equals minus b. And before doing that, what I will do is the most cryptic part of the calculation is this part, which is my discriminant. Yeah. So b square minus 4ac. Let's find out this thing. So b square minus 4ac. So b square is minus 57 square minus 4a is 16 into c is 49. Wonderful. Now you guys will have to use the calculator. How much is the value of discriminant, David? If you have your calculator handy with you, or else you want me to do this multiplication quickly. 49, 35, 39, 535, 535 plus 328, 9, 4, 2, 3, minus this 16, 49, 4 days, 196 multiplied by 16, 16, 16, 96, 16, 144 plus 9, 154 plus 9, 153, and then 16 minus 16 plus 14, 30. So I got 3039. So this is 999 is 0, 4 minus 3 is 1, 2 minus 1 is 1, 110. Is this the value for this discriminant, Tariq? Or shall anybody having calculator with him or her? Anyways, whatever be the case, okay, if this is right or not, let's assume this is right. And I'm just rounding it to 100, okay? I'm just rounding it to 100 for the sake of simplicity. Maybe I picked up a little big calculation, but that's okay. Let me round it to 100 because so that 100 square root of 100 will give me a 10. Okay. So when I put that value here, x equals minus b. B is minus, where did it go? B is minus b. So minus b is 57 plus minus square root of 100, that is 10, by 2 times a. A was my 16. 2 times 16 is 32. So minus plus 57 plus minus 10 by 32. So these are two values of x. Yeah. So one value when you take a plus value, that is 57 plus 10 is 67 by 32. It will be 67 by 32 will be like 2 point maybe 1. Okay. And when you take a minus, 57 minus 10 is 47 by 2. That will be like maybe 1.5. Yep. So all that I have done so far, is that part clear so far or looking complicated? What did I do? I had this radical equation. I did a square of this so that I convert this to a quadratic equation. From that we found a quadratic equation and then we applied the quadratic formula to solve it for x. We got two values. Okay? 2.1 and 1.5. Okay? Let me further try using a simpler value. Okay? I don't want to spend a lot of time to worry about the minute calculation, but there's an intent behind what I'm trying to do. So we got 2.1 and 1.5. So these are the equations I have. So when I put 2.1 here, there are two values, okay? When I take 2.1 as the answer, plug in here and see what is happening. When I take 1.5 and plug it in here, let's see what happens. When I say 2.1, so square root of 2.1 equals 4 times 2.1 minus 7. Okay? So 2.1 square root would be approximately 1.5. Approximately 1.5, okay? And this is 4 to the 8.4 minus 7. So this is 1.5 is equal to 1.4. 1.4. Again, I have done approximation, so this looks okay. I mean, barring all the mistakes I would have done during the calculation, this seems to be okay. I mean, this value that we got for x is fitting in here somehow. Now, I wanted to show you guys something interesting to prove myself wrong. I mean, not trying to prove myself wrong, I'll not be my own enemy, but I'm trying to show you guys an interesting concept. So, when we put 2.1, we had two answers for x, 2.1 and 1.5. When I put 2.1, it looks to be okay, reasonably okay. Now let's put 1.5 and see what happens. When I put 1.5 in this equation, this is 1.5 square root equal to 4 times 1.5 minus 7. 1.5 square root would be somewhere around 1.2, 1.25. Okay, equal to 4 times 1.5 will be 6 minus 7. Oopsie daisy, there's a problem. Because 1.2 is equal to 6 minus a bigger number, which is minus 1.2 maybe. And this is not true. This is not to be believed, no matter how loud I am when I'm saying so. This cannot be equal, right? 2 is not equal to minus 2. Yeah, this, if you consider plus as my earning and minus as my loans, if I say I have 2 million earning versus 2 million loan, this is not the same. Correct? What did go wrong? Any thoughts? So first of all, before I kind of bug you guys further, what did we do so far? We had this equation, a radical equation, and we had to solve it. We said, okay, fine. Square root of x, it's not easy to deal with. Let's square both the sides so that, no, I mean, if I have 2 equals x, if I square it, it will become like this, right? So far, no problem. So that's what we did. We squared it and converted to a quadratic equation. We took the quadratic equation, applied the quadratic formula, and we got two answers for x. And what we are seeing is when we are applying, see, by solving this equation only we got this solution. Meaning, if this is the mother, these are the kids, part of the same family. Now I'm saying, okay, with this mother we got these two kids. Are these two kids related to this mother? That's what we're trying to do here. And what we are seeing is, this kid looks okay. This kid is having problem. Now, I want to know why it has happened. What has gone wrong? And I want you guys to get a little stressed out. Meaning, stressed out doesn't, not to get stressed out and get worried. I want you guys to think about it. Ritika, Jenna, Ananya, Neil, Sara, Davik, Viswa, Vishal, Moksha. Tell me what is going wrong here. Where did we go wrong? I mean, apart from considering the fact that your teacher was wrong with the way he solved it. I did not make any mistake, for sure. Okay, I'm guaranteeing you guys that I did not make a mistake. There's a hidden concept here that is called extraneous solution. You got a solution here, but that is extraneous. That is, let's say, when you're dealing with a situation like this, when you're dealing with a radical equation, when you square it or do a cube of it, you will come across some solutions, and out of all the solutions, some solution will not satisfy this equation, which was the origin of the whole problem. And that is called extraneous solution. Okay? And we are witnessing an extraneous solution, which is very normal in case of a radical equation. And the root of this whole problem is this. Anybody who has any idea around this one, who wants to write a story before I go on? Or you guys are waiting for me to describe it? Any thoughts? Vishal, Davik, Ritika, Nanya, anybody? Neil, Saurav, Thansi, anybody? Priya, any thoughts? Why this is happening in case of a radical equation? No? Yes, Thansi, go ahead.
Is the question wrong itself?
I'm sorry, Rita?
Is the question itself wrong?
One more time.
Is it the possibility the question could be wrong, like the way to vote it?
No ways. This is a concept that comes along with the radical equation, okay? Sorry, Rita? It has only one solution. Other one is a extraneous solution that doesn't fit the bill. Now let's look at this way. If I put, instead of x, let's say if I put a 4. Let me give you guys a simpler equation so that you can relate it. Let's say I have the square root of x equals x minus 1. Okay? Now let's try putting, let's say we try putting, by solving this, let's say we'll get 4 as an answer. I'm just putting it here for the sake of simplicity. When I do a square root of 4, it gives me 2, and this is x minus 1. Okay, this is not the right definition of this. Let me keep it here. I'll just keep it here. Okay. I mean, this is not the answer. That's why it's not fitting it here. But let's say if I'm trying to solve it for 4. Okay. Let's assume that my answer is 4. When I'm doing a square root of 4, what all I will get? Plus 2 and minus 2 both, right? Plus and minus 2 both, correct? What we did in the solution was, we assumed that there's only a plus with which we progressed. And this minus part was ignored. That is where we went wrong. So if you have an equation like this, if you do, let's say if you have an equation like this, if you do a square of this will be equal to 4x minus 7 squared as well as minus 4x minus 7 squared also. Because this minus into this, when you're doing a square of the whole thing, this minus into minus 1 to minus 1 will become plus, and this will remain as this. What is happening is the minus part we are missing, and that minus part, when you take into consideration, that is when your extraneous solution will not come into play. for the sake of simplicity, you can assume that when you are doing a square of this one, so the square root of x will give, let's say, some value. Let's say it gives 1.5. We are only looking at 1.5. You have to look at 1.5 plus and 1.5 minus. When you look at both the scenarios, then the extraneous solution will not exist. So it's all happening because you had to get a square root of something, and you only consider the plus part. That is why you are only getting extraneous solution actually. Yes or no? Or in the simplest way, when you do a square root of x, let's say a square root of x, and if the x value is 9, you have to look at plus minus 3 both. But when you do the calculation, we lean on only the plus part. That is where this whole thing goes wrong. In the beginning itself, if you say that this, I'll put a minus 1 in the beginning. I will take one scenario with a plus 1 minus of square root and one with a plus of square root of x, and then when you continue further, you will not come across the extraneous solution. Or other way to look at it would be, you have to find out square root of something, and we tend to look at only the plus side of it. When you look at plus and minus both the values and then substitute it, then it will be fine. Because in this problem when we were solving, we got 2.1 and we got 1.5. So if we would have looked at 2.1, this was fine. If you validate this whole problem for minus 1.5, then you will see this one works. Let me put minus 1.5 and see what happens here. Okay. If I put the x value is minus 1.5, no, then this becomes unrealistic. Okay. So anyways, square root of minus 1.5, we cannot solve this one. So okay, let's not make it too complicated. First thing first is, when you are looking at a radical equation and you are trying to solve it, obviously if it's a square root or a cube root, you will square both the sides or do a cube of both the sides to get to this one. When you find the values, you will find that when you get the solution of this one and you fit the same value in this equation, one of it will work, one of it will not work. That is what is called extraneous solution. And the reason for that is because when you get the absolute value of the square root of this number, you get a plus and a minus value both. Since we are ignoring the minus value, that's why we get that extraneous solution. That's the root of this problem. Did I get you guys confused a lot, or somewhat you able to relate?
I'm able to relate.
How about you, Moksha? A roller coaster for the first day. It's okay. Okay. So let's do one thing. Now, so far what we have done is we just looked at what is a radical equation, what is a rational equation, what is a absolute value equation from a definition standpoint, and we looked at solving one problem, and I tried giving you guys a glimpse of what is extraneous solution. Let's solve few problems today and tomorrow, and then we will deal with the extraneous solution situation as well, and then we will come back to this concept and try relating that. Okay? Kansi, Jana, Ria, Ritika, Vishwa, everybody okay?
Yes, sir.
Neil and Sarah okay? So let's look at some problems. See, it's working. So let's look at some problems and try solving it. And we'll see how are we able to do justice with the problem. Okay. Let me go to the questions that I have put across for you guys. Let me pick one question here. I have an equation, square root of y into y minus 15 minus 4 equal to 0. And this question says, what is the sum of all the solutions to the given equation? So we have an equation like this. Obviously it's a radical equation. Yeah. We have to solve it and says, find out what is the sum of all the solutions for this equation. Now, how will we go about it? Any idea? No idea. Okay. So if it's a radical equation, when you have a square root, obviously first thing you'll do is you'll do a square of this. Okay? So that you get rid of this annoying radical symbol. Okay? So what you will do is, okay, let's keep this thing here and make 4 move to the side. Now I have a square root of this thing on one side and 4 on this side. Square both the sides, it will become y into y minus 15 equals 4 square. Right? I did a square of this and a square of this. So we got this. So this becomes y square minus y into 15 is 15y equals 16. That is y square minus 15y minus 16 equal to 0. This is the quadratic equation we got. And we can solve this to get the value of y. So again, what is my ABC? My standard form of the radical standard form of the quadratic equation is ax square plus bx plus c equals 0. Correct? So I'll relate it with this guy and find out the ABC value. A is equal to 1, B is equal to minus 15 and C is equal to minus 16. So I'll apply this quadratic formula, minus b plus minus b square minus 4ac by 2a, and let's look at what is the value of this one. So b square minus 4ac is minus 15 square is 225 minus 4ac minus 4 into 1 into c is minus 16. So this becomes 225 minus into minus is plus 16 into 4 64. Yeah. So this becomes 9, 2 plus 6, 8 and 2, 289. The square root of 289 is how much? The square root of 289. 13 is 169, 14 is 17 is how much? Yeah, 17 is square. Yeah. So square root of this is nothing but 17. So this becomes minus b. My b is minus 15. So minus into minus 15 plus minus 17. Square root of the whole thing give me a 17 by 2a. My a is 1, so by 2. So this is not x, sorry, my bad. This is y. So y equals, this is plus 15 plus minus 17 by 2. When I take a plus value, this becomes 32 by 2, that is y first value is 16. When I take a minus value, it becomes 15 minus 17 minus 2 by 2 minus 1. Okay? The question says, find out the sum of the solution for this one. So first thing that will pop up in our mind is, just add them together. 16 and minus 1. That becomes 15. Is that correct? No, I have already seeded an element of doubt in your mind. That whenever you are dealing with a radical equation, there is a possibility of an extraneous solution. So one of the solutions may or may not be right. So let's check. Let's put this value here and see what happens. When y is 16, so it becomes 16 times 16 minus 15 is 1, square root equal to 4. So this one looks okay. 16 looks okay. When we go to minus 1, what happens? Minus 1 into minus 1 minus 15. Square root of that equal to 4. So this is minus into minus 16, minus 1 to minus 16 is plus 16. Yeah. So this solution is also okay. In this scenario, we don't have an extraneous solution. So sum of both the solution, you will just add these two numbers and you will get it. That will be 16 plus minus 1, that is 15. That is what will be the solution for this problem. So if I go back to what the problem was, we were given this equation, square root of y into y minus 15 minus 4 equal to 0, and we have to find out the solution for y, the values for y, and give the sum of both the solutions. Give the sum of y, all the y values we got by solving this equation. Yeah. So we did that. So here, if you look at what we were doing so far before I seeded this element of doubt in your mind was, we will just solve this equation and we'll get the value and add them up. Today when we were talking about extraneous solution, in case of radical equation, we said okay fine. By solving the equation, whatever value you get, make sure that you are plugging in those values in the equation and verifying whether those answers are correct or not. Yeah. So that will become a regular practice for you guys here. Okay. Because any equation that you look at is not going to remain as innocent as you would want it to be. Sometimes an equation could give you a misleading answer, which we call as extraneous solution. And you have to verify those solutions before you give the answer. Otherwise, during the exam, you will always think that, okay, my answer was right, I did not make any mistake, I applied the quadratic formula, I did all my calculation. But still, I did not get the perfect score that I wanted. That is because of this small mole that we call as extraneous solution. Okay? And that will be more prevalent in the case of radical equation, because when you are looking at a radical equation, imagine this is a number. If this number is 100 or 250 or whatever it is, square root of that number, whatever this value comes from this one, square root of that will have two values, one is positive, one is negative. For all the practical purposes, we tend to ignore the negative side of it. And that is what leads to the extraneous solution. Yeah? Is everybody with me so far, or I'm just blabbering in air? I'm sorry, Beta? You understood? Wonderful. Ananya? Vishal?
Yeah.
Clear? And again, as I keep saying, okay, and saying that to Moksha also without any shame, that I'm not the best teacher. I'm just trying to explain something. So I might make mistakes. If I make mistakes, if I don't explain things very clearly, you have all the reasons and rights to ask me. So don't say, okay, no, maybe no, he's saying something, I probably, it was my mistake. It's not never your mistake. It's always the teacher's mistake if the things are not being made clear. Okay? I'm the enemy of this gang called teachers. Okay? Because I graduated to become a teacher, right? I was never a branded teacher. I was more of a student, and I'm still a student, I believe. So that's what we'll keep approaching. That will be our approach always. Okay. This time I'm going to give you guys a runway to solve this problem, and let's see where you guys get stuck and what direction would help you guys solve it. Okay. This time I'm giving you guys a problem which is more of a problem relating to a rational equation. So that will be similar to how you solve any quadratic equation or any polynomial. Let's see how you are going to apply this concept and how do you deal with it. This says 3z plus 2 divided by z minus 2 plus z minus 6 divided by 3z minus 6 equals 6z minus 4 minus 1 divided by 2z minus 4. Okay, so I'm just reading it. 3z plus 2 divided by z minus 2 plus z minus 6 by 3z minus 6 equal to 6z minus 1 divided by 2z minus 4. What is the solution to the given equation? And these are the options that is given to us. Options given to us. We have been asked to find out what is the solution to the given equation? Meaning, what is the value of z? Equals minus 3 by 2. Second one is z equals minus 2 by 3. Third is z equals 2 by 3. Fourth is z equals 3 by 2. And while every problem we can solve in different possible ways, I keep teaching or educating the kids or guiding you all to say try solving it without even solving the problem. There could be some problems which you don't need to solve. You have to eliminate some options and then you get to the right answer. Yes, Sarah.
Is it 2 minus 6 or z minus 6?
Z minus 6 better. First term is z. It's 3z plus 2 by z minus 2. Z minus 6 by 3z minus 6 equal to 6z minus 1 by 2z minus 4.
Okay, thank you.
So I want everybody to get their hands dirty. Try solving this problem. Give it a try. Give it a try. It's perfectly fine. What happened, Vishwa? I see you with emoji like this. Thinking about it. Davik, Ritika, Jana, Thansi, everybody giving it a try? Or, yeah, okay. Vishal. Okay. I'll give you guys 5 minutes to give it a try. And then, yes, Vishal.
I got z is equal to negative 3 by 2.
Negative 3 by 2. Okay.
Yeah, option A.
Option A. All right. I mean, I'm pleasantly surprised that you already have an answer. So I'm certainly curious to find out how are you able to solve it real quick. And I'll let you speak through that. Let's give everybody 2 more minutes before we start. Before I come to you. And between today and tomorrow, okay, this whole topic, we'll do enough practice, okay? We'll solve 10-15 problems between today and tomorrow so that we get more and more comfortable with these concepts and application of those, okay? Yes, Nanya.
I got the first one.
You also got the first one? Interesting. Okay. Now, when I say interesting, that doesn't mean I have any doubt about that being the answer. Interesting because I'm happy that you guys are able to get to the solution of it, and it'll be a bit of a ride for Moksha for today. It's okay with her, okay? We'll see. It's like I'm throwing you guys in a swimming pool without asking whether you have enough swim before or not. So don't worry about it, okay? Just give it a try. Okay, how about Ritika, Vishwa, Thansi, Sarah, Neil, Ria? Ria has been very quiet for last few days, for last few classes rather. Davik, what's happening?
I thought it was 2 instead of z, so now I'm restarting.
Okay. So, just in the interest of time, okay? I'll probably give you like 1 more minute, and then so that we can use the remaining 7 minutes to kind of brainstorm all the options that we are getting to hear from some of the kids, and then see if there's anything that we want to improvise. Yes, David.
It's A.
You also think it's A? Okay. Now, knowing that we have knowing that but it was we have not gone through the more concepts of rational equations, but I kind of threw you guys to solve it. Let's see. I'll start with Vishal. Vishal. So Moksha, everybody else, okay? Let's hear Vishal. Vishal, tell me, what did you do to get to A, and why you think it's A is the answer?
So first, I figured out we should solve the one side of the two sides. So I set for the first part to multiply by 3, so the denominator is same for both of them. So when I did that, I got on the top 9z plus 6. And so basically I just did 9z plus 6 plus z minus 6. So that's basically 10z on the 10z by 3z minus 6 on the left side. And so then I wanted to get the common denominator for both sides. So I multiplied the left side by 2, which gave me 20z on the top. And then I multiplied the right side by 3, which gave me 18z minus 3. And I just solved for a z, and I got z is equal to negative 3 by 2.
Okay, Davik. Same approach, a similar approach.
So what I did first was I saw that they can all all the denominators can all be z minus 2. So I did z minus 2, 3 times z minus 2, and 2 times z minus. Wait.
Okay.
2 times, yeah. So
Yep. All right. So here's the thing. So Rudraj, you have come 4 minutes early, so you are here, but you're not here. Okay. So I don't want to hear even a single drop of a pin. Okay. No sound. All right. So here, look at this. This is where Moksha will learn something today, and she will get tired of it. So there's a concept. Some of the kids already hate me for this, okay? I've talked about it so many times. When you look at any problem to solve, this is a magic word. I call it RAN. Who wins the race depends on who ran the best. Now if you look at it, R stands for read, A stands for analyze, and then N stands for Nike. You're putting on Nike shoe? Yeah. Nike, what does Nike say? Just do it. So basically when you're solving a problem, read, analyze, and then try doing it. Where we go wrong is we jump onto this stage. Okay? So I will keep reiterating this because this will become life for all of us. So you are here but you're not here. Sit down without making any sound. Okay? So when you look at this, now read, analyze. When you're reading this question, okay, this looks to be a cryptic one. If I go the normal LCM way and do this calculation, I'm going to blow it up into a big calculation. Okay? While you guys are waiting, put this. Oops. So now when I'm reading this and analyzing it, my first attempt is to always simplify it. And how do I simplify it? Z minus 2, 3z minus 6, do not make it sound. 3z minus 6 and 2z minus 4. So the coefficient is like, the constant is has a value which is 2 times the coefficient required. So z minus 2, 3z minus 6. Okay, that means if I take here 3z minus plus 2, I can write this as z minus 2, that is okay. Plus z minus 6. Here if I take 3 common, this becomes z minus 2 equals 6z minus 1 by 2. If I take 2 common, z minus 2. Oh, I got everything common here. Okay? That means now I will take z minus 2 out in the whole equation. Okay? So this becomes 3z plus 2 plus z minus 6 by 3 equals 6z minus 1 by 2. This is my equivalent equation, which is much simpler than what it was looking before. Yeah. So now you can say, okay, fine. This becomes 3 times 3z plus 2 divided by 3 plus z minus 6 equals 6z minus 1 by 2. And now you have a much simpler, cute looking equation that you can solve. Yeah. From this, whatever value you get, I will trust you guys for the solution that you get. But the key lies in the way you analyze it. If I would have tried solving it the regular LCM way, like adding fractions, that would have been a massive task. But as soon as you simplified it, when you were thinking through it, you noticed that okay, z minus 2. Here if I take 3 common out, z minus 2. Here I take 2 common out, z minus 2. Well, that means I can take this out. This is my equation that I am trying to solve for. Okay? And this one, see, this into this is equal to, this is just like, finding the equivalent equation. So you just found the equivalent equation. This one doesn't have anything to do here from a solution point of view. Okay? So just look at this one, you can solve this. Does it make sense to everybody? Davik, Vishal, Ananya I think dropped off. But is this approach okay to everybody?
I'm still here.
Yeah, oh okay. Yeah, Ananya, you had dropped off and you joined back. Okay. So but yeah, this you took the same approach, I believe, correct? That's the only way you can solve it quickly. If you do the regular way, regular calculation, it will take a little longer. So all the kids from level 1, you have put on the headband. You don't have reason to play with that and make any unnecessary sound, right? Okay. So come on in. Okay. So always the key guideline for all of us is when you have a problem to solve, you don't have to solve it without thinking about it. And that's what I keep stressing on, saying read, analyze, and then you try doing it. When you analyze it, you were able to make it simpler, and then doing it was even simpler. Keep moving. Alright? So with that being said, I'll let you guys go, and we'll muddle the water more in the class tomorrow. Yeah?
That's it.
Bye bye.